Hello, my name is Alison Proctor, and I am the AUV Program Manager at Ocean Floor Geophysics. Today, I'll be talking about remote support for offshore operations and our experience providing specialist support to our offshore AUV team over satellite communications. Last year, Ocean Floor Geophysics conducted an offshore autonomous underwater vehicle survey in Brazil. With the COVID-19 pandemic limiting the capacity for international travel, OFG launched a new remote support program which enabled specialists around the world to participate in the survey remotely through low bandwidth vessel-based satellite internet. The resulting system enabled the completion of a 3-month survey with an offshore crew that was composed primarily of domestically available operators with support from an array of international specialists. First, a quick overview of my presentation today. First, I will describe what I mean by remote support and discuss the motivation for investigating this new way of working. Then I will talk about technologies that we employed and how we were able to use them to reduce the number of personnel offshore. And then finally, I will discuss our future goals with automated processing and the conclusions that we came to. In this case, remote support was used to enhance our offshore survey team and provide easy access to shore-based specialists. So a couple of ways we can enhance our offshore team. Number one, we can make shore-based specialists available to assist with short, specialized tasks such as calibration or setting up new equipment. Number two, we can increase the availability of information and specialized knowledge when trying to solve problems offshore. And three, we can move administration tasks back to shore-based resources so that we can use our offshore personnel a little more efficiently. For OFG, there were 3 main reasons to pursue this objective. Number one, to reduce the offshore contact hours. So offshore operations are intrinsically higher risk than onshore operations. So minimizing the offshore team can be used to reduce the total project risk. And further, with the smaller offshore team, it can be much easier to find vessels of opportunity to complete the work. Second, a globally distributed onshore team is much more flexible than an offshore team, which is attached to a vessel. So offshore personnel are fixed. They must be organized well in advance, and they're constrained such that they can only be changed during port calls. Whereas onshore people don't require visas for travel, and they can be engaged as necessary with very little lead time. And then, of course, the main reason that we're doing this now is to mitigate risk due to COVID-19 and international travel. So currently, projects that rely on international travel are taking on a significant risk due to the constantly changing restrictions with travel and quarantine. Onto the technology needed for remote support. If we're going to provide solid shore-based support for our offshore teams, then we need a good data connection. And with innovation in satellite communication technology, this is becoming feasible. So a dedicated satellite connection with 20 megabit per second sustained and a burst of over 50 megabit per second can be achieved today with existing systems. And tomorrow we'll be able to do even better than that. But more connectivity also means more IT vulnerabilities. And a good relationship with the satellite communication network provider is definitely key to maintaining security and connectivity. So for this project, we actually had a dedicated fiber that ran from the satellite provider directly to the onshore data center so that none of the network traffic to and from the vessel ever touched the internet. And any external users accessed the data center first through secure means, and then were able to access the vessel from there. With a secure and stable data pipe back to the beach, then we need to budget our bandwidth wisely for the tasks that we want to do. So we had excellent success using the ClearComm LQ series IP interface and Agent IC to tap into the vessel's existing analog ClearComm communication system from remote locations. It was extremely efficient with bandwidth and gave us 2 channels of communication for 32 kilobits per second. This gave the onshore team the ability to track and verbally participate in offshore operations. And we used the system extensively for meetings, operations, troubleshooting, and just checking in. As you can imagine, video feeds are essential, and there is literally 100 ways to set this up. For this work, we chose to use a 4-channel H.265 video encoder and to transmit the image from 4 monitors in the operations center. So 3 of these monitors were displaying AEV mission information, and one of them displayed a camera view. So with this setup, we were able to choose readily available H.264 IP cameras and still get the benefits of H.265 compression without needing to transcode the streams. It worked really well. We had an excellent resolution and frame rate on our 4 streams for less than 1 megabit per second of bandwidth. And once the video feeds were onshore, they were rebroadcast out to our onshore team from a media server, so that there was only one feed coming from the vessel, and the media server handled the many connections required by the onshore team. With the access to the mission screens and ClearComms, I was able to sit at my house in Canada and work through mission planning or troubleshooting or anything else with my offshore team. One of our goals was to freely provide the information that the onshore team needed so that they were not always asking the offshore team questions to get their work done. To facilitate this, we implemented a chat server that the onshore and offshore teams could use to communicate easily with each other, and then implemented many different bots that would announce the state of different processes like data copies and backups. We also implemented a browser-based dashboard which showed the relevant information about the AEV so that someone who knew the mission plan could easily determine where the AEV was and how long it would be until the next recovery. To ensure that everyone had access to the same information, we also used OneDrive to synchronize a shared drive on the vessel with a SharePoint site on land, so that the onshore team could work on most of the documents locally and everything would just magically be available on the vessel. Lastly, we also implemented TeamViewer so that we could delve deeper into the onboard systems when necessary. We used TeamViewer to manage servers and backups from shore, as well as providing specialist support for installations, calibrations, and navigation. With all of the tools in place, the goal was to move some of the roles on our org chart from offshore to onshore. But some roles just can't be moved. So there is a minimum number of personnel that are required to safely conduct offshore operations. For Hugin AEV launch and recovery, this is 3 people per shift. Similarly, there needs to be an offshore manager, and that person needs to actually be offshore to be able to do their job. Then there also needs to be a qualified processing and interpretation team that can ensure that quality standards are met for the data. The people that go offshore in this role need to be highly skilled so that they can debug problems and keep things going if there are any hiccups with the remote support system. And lastly, with the introduction of so many technologies in the critical path for operations, there also needs to be IT support on the vessel to help when things stop working. So then, what roles can be moved to shore? Extra administration. So sometimes on big projects where multiple companies collaborate, there is necessary but redundant administration offshore. When the onshore team is properly immersed in the day-to-day activities offshore, then these extra team leaders or client reps can successfully work from shore. Second, equipment specialists that don't have a real data collection function during the survey can also participate remotely. For example, an expert that could easily manage the HIPAP calibration from shore using the tools that we have presented here. And then lastly, the data processing team. So a full team of data processors is not required for safe AEV operations, but how do we reliably produce our preliminary deliverables without that team? The amount of data produced by our AEV is just too big to get off the vessel over a satellite connection. So a shore-based data processor has to be able to process the data on the vessel from a remote location. Now, the data processing team can access the vessel through TeamViewer, but trying to operate data processing software over a slow data link with high latency is definitely not fun. And we need to be robust to network dropouts where the data processors are prevented from accessing the vessel for extended periods of time. So our approach, number one, automate as much of the processing as possible to keep the data processing cadence, even if the person that is monitoring the workflow is unavailable. And two, try to reduce the number of mouse clicks. So we partnered with Teledyne Keras to develop a system that could meet these goals. So using Process Designer and Keras on board, we were able to automatically initiate all of the data processing workflows, and the data processors spent their time monitoring the processes to ensure that everything was working correctly rather than running the processes themselves. And then the final piece for minimizing the number of mouse clicks is Mira AI. This is the Teledyne Keras AI-based cleaning tool. So between Process Designer, Keras on board, and Mira AI, it is possible to automatically generate all of the onboard deliverables automatically. Now, this does not remove the need for a data processing team. We still need people to babysit the processes and run quality checks, but for many types of surveys, this all can be done remotely. Our experience with remote support was very positive. The offshore team really embraced the concept and attempted to use the new resources to improve the field campaign. Enabling specialists to assist remotely can definitely fill small holes in the team's competencies, but we still needed a really strong team offshore. Reducing the number of personnel on the vessel means that each person offshore really counts, and then they must be skilled at the job that they do so that they can perform it efficiently. Similarly, the onshore team needs to be very familiar with offshore operations so that they can easily integrate into the team without actually being there. New software and technology developments with improvements in functionality and security are required. We were incredibly successful in meeting our conservative goals in this project, but that just left everyone, including the client, wanting more and wanting to know what else we could do. But even with all of the success that we felt, it was clear that there were some surveys that can't be done with a remotely located processing team, such as those tricky shallow areas where the data processors are making real-time decisions about when to take sound velocity, how to run a line to get the best data, or having to process each line manually rather than through the automated system. In this case, it is still best to have a big enough data processing team offshore so that we can make the necessary decisions and ensure that the highest quality of data is collected. At OFG, we are looking to build on this experience by facilitating new cross-discipline survey concepts and enabling scientists to interpret data remotely to get a more synergistic evaluation without any restriction on team size due to vessel or logistical constraints. This program provided valuable insight into developing best practices for reducing the number of crew offshore and for relying on remotely located specialists to ensure the consistent delivery of high-quality data products. This work has also provided a technical and procedural framework for demonstrating the remote bathymetry and side scan imagery processing solutions that are available through Teledyne Keras. Keras will continue to develop their remote processing tools, including a new suite of native web-based software, and this development is part of an ongoing collaboration between OFG and Teledyne Keras that is supported by Canada's Ocean Supercluster. The partners in the Ocean Supercluster project are Teledyne Keras, Ocean Floor Geophysics, H2I, CIDCO, and the Canadian Ocean Mapping Research and Education Network, including the Ocean Mapping Group of the University of New Brunswick and the Marine Institute of Memorial University of Newfoundland. Thank you all very much for attending my presentation.